I'm going to talk about enriching Kafka applications with real-time contextual data with Hazelcast. Now, Hazelcast, some of you do know Hazelcast. Most people know us as a caching solution. What people do not realize is that it's also a caching plus streaming platform. And our philosophy is about doing things and catching things real time. Now, real time for us could mean while the customer is banking. For example, while the customer is at the ATM, provide the customer a loan offer. When the customer is shopping, or when actually a fraudulent event is actually happening, before a process breaks, right? While the travel is en route, and so on and so forth. Basically, the idea is to capitalize at the event and prevent bad things from happening real time. The slide basically, I do not have a lot of slides. So this slide is basically saying the value of your business increases as you act more and more real time. Traditionally, more we do batch processing, pull that data, transform that data, hold on to the database for a very long time, and then probably process it later. Moving on to a bit of streaming ETL, pull that data, transform that, store it, analyze it. But what we say and what we encourage our users to do is, as you pull that data, transform it, whatever you want to do, act on it at that time, and then go ahead and store it if you want to. And then add ML or all of that in the data as it streams, right? So this slide basically talks about what is Hazelcast made up of. Now, we like to call ourselves a unified real-time data platform. Why do we call ourselves unified real-time data platform? One is everyone knows us, or at least who do know us. They know us as a cache. So we are a fast data store. Yes, we are a very fast data store. But we are also a compute platform because we run distributed. We run on multiple VMs, nodes, servers. Well, that has also the compute power. So we are able to utilize those compute power. And then what do we do with that? Well, we are then able to, I do not have a pointer, but on the left hand side, basically it just shows that Hazelcast platform can be connected to various sources which may be streaming data in, or maybe they're batch sources, files, bank-to-bank transfers, right? Is an interesting use case. Bank-to-bank transfers are for a country's regulator or for a country's central bank. That's a large amount of data. Some do rely on Hazelcast to basically process that huge amount of data real time, move it inside Hazelcast, and then take advantage of data what is already residing inside Hazelcast and the compute which is distributed and parallelized, and then act upon that data. And the platform allows access via SQL, via the application, various language clients, and being a distributed system, we come with certain choices for users on availability upon failure or consistency upon failure, and so on. So now we'll look at a question comes that, well, Kafka, Hazelcast, what are you guys talking about? So we'll look at a demo where I'm going to read something from a Kafka stream. I'm going to read messages from a Kafka stream, and I'm going to enhance and enrich those messages and then push it out and display it and push it out. And I'm going to do two things. One, I'm going to basically read a Kafka stream and enrich it with data stored inside Hazelcast, the enrich events. And another quick one I will do is that I will have two streams and then basically combine them using Hazelcast and then do something about it. So let's move to slides. Sorry, code. So what I'm going to do is that first I'm going to, oh yeah, I can do this. I'll make it easy for all of us. I created a project in GitHub. You all can follow that. And the steps basically say, first start Docker. That's what I'm going to do. I'm going to run a Kafka container. It's running. Then it will say that, well, you can start Hazelcast, and there are some installation guides on Hazelcast, so you can just follow these links. And simple Hazelcast installation, you can ignore the enterprise bit. And then you can also start the management console, right? So the management console is something that you can use to monitor Hazelcast. Oops, it's too small, I think. And then we will use something called the command line client. It's a client tool for accessing Hazelcast. So it's a standalone tool written in Go. And we use that to, well, talk to Hazelcast. So we'll do that. So let's go back. Yeah. Now I'll start Hazelcast. So I've installed Hazelcast using Brew. Nothing too complicated. Hazelcast typically minimum 3 nodes have to be running. It's just that's just for real deployment, but this is only an demo. So we will just start one instance of Hazelcast. Hazelcast is up and running. Those who have used Hazelcast do know that, well, it's a Java. It's built on Java. Okay, going back. Let's look at what we have. SQL, right? So now I did tell you that there are multiple ways in which we can talk to Hazelcast. One of them is the SQL interface. Hazelcast is ANSI compatible for a subset of the language. So I will run CLC. CLC is a Hazelcast command line tool. -C stands for the config, and which there are multiple configs. Like everything else, you can connect to this cluster or that cluster. So my cluster is called dev. I'm connected, and straight away it drops me to the SQL interface. Now in this SQL interface, what I'm going to do now, I have to read Kafka. So if I have to read Kafka, I have to create a mapping into a Kafka topic. So this piece of code, this SQL, is going to create a mapping into a Kafka topic, right? And the topic will be called orders. I'll do that, and the mapping is created. No data is flowing. I can do a simple select. Nothing is happening. Nothing is happening because nobody is actually pushing any data into that Kafka topic. So what I'm going to do now is that I'm going to start pushing some data. So here's an SQL. Again, it's a proper SQL that uses an Hazelcast function to generate data. So I'm going to use this SQL not like this, unfortunately, a bigger SQL, but it's sort of easier to understand. I'm going to use this SQL to generate the data. This is the code. As you can see, the final from is on top of that, and then we are going to put some columns on top of that. But what is this SQL doing is that it is creating a job, and this is the compute part of Hazelcast. So you basically deploy a piece of code inside Hazelcast. In this way, I am doing it via SQL. Typically, people do that in production using Java, but SQL works fine for ad hoc and, well, for some interesting features coming soon. So SQL. So I'm going to copy this whole big SQL, and this SQL, just a reminder, is going to deploy a job. And what that job is going to do is going to read from this no, it's not going. Yeah, it's going to generate this data and is going to push the data into the Kafka topic, because, well, somebody needs to put data into the Kafka topic. So it's going to be this sample code. Now, this has actually started pushing the data into the Kafka topic. Oops, this SQL was running as a little while ago. It wasn't showing any data, but now it is. I'm going to stop it now. Just a reminder, this was a SQL on that Kafka topic. This is a continuous query. It is continuously reading data from the Kafka topic into Hazelcast. Now, once you have pulled the data into Hazelcast, you are then able to match it, map it, act upon it real time. We keep using the word real time because everything is in memory. I can now start, putting some queries into this. So now I'm querying the Kafka topic using SQL, putting conditions and so on and so forth. So I'll skip that bit. I'm going to do is enrich the data. So how am I going to enrich the incoming data? First, I'm going to create some sample data inside Hazelcast. Those who have used Hazelcast, a map is a typical typical data store, typical data structure. So again, I need to create a mapping to an IMAP, right? An IMAP is what we internally call the map topic created. And then I'm going to push some random data into this map. Again, just reminding ourselves what I'm trying to do. I am streaming in data from Kafka. I'm creating a map inside Hazelcast. Then I will match the two and push the data out. And here is the enrichment SQL. We'll just spend a few seconds in it. It is doing a select, blah, 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 not important, from orders. Orders is the name of the Kafka topic. Join, enrich. Enrich is the name of the map, the data that is contained within Hazelcast. So using SQL, in this particular case, we are joining streaming data with static data inside Hazelcast. And as an example, now here we are enriching the incoming stream. So copy and boom. Sorry. Now again, it'll go on printing. It'll go on printing. Again, why is it going on printing? Because data is streaming in from Kafka, and we are merging that data with some data we have, and then printing it out, right? We fired an SQL. What else did we expect? But then that's not what people want to do. They don't want to look at the screen. So maybe they will write another SQL to push another so we're going to push this data into another map. Copy. Again, we are creating some mappings and such, not important, but the fact is that we are again creating a job here, a piece of code that will run, that is now going to read data from the incoming stream on Kafka, merge that data, merge it from here, as you can see, and push that data into another map. So now what we have here is data going into the destination map. I can do a select star from destination map, and that's the data. This is data already stored inside Hazelcast. It is not a streaming data, right? It's not a streaming source. A map is equivalent to, analogical to, a table in database. So you query it every time you get more records because data is streaming in. And this is an example of a simple example of Hazelcast enriching incoming stream of data. I can do the same with two totally different streams of data coming in, merge them and push that out. So going back, the idea here was to demonstrate to you that you use Hazelcast to not just hold data, but you use Hazelcast to process incoming data. Another example use case, which I'll be demonstrating tomorrow, data coming in a Kafka topic where it says source. It's sort of an internal structure, and we can embed Python process within the distributed cluster, and you call that process basically a ML algorithm. It's an inference call, and then push it out into Kafka topic. A typical example, and probably I'll do this tomorrow, a typical example is what is that thing called? Fraud detection. So a typical use case is fraud detection. When a card is swiped, data comes into Hazelcast. The swipe data goes into Hazelcast, and Hazelcast, by nature of it being distributed in parallel, is executing 5 different ML models, for example. All of those 5 are executed in parallel, and the result, or the majority of that result, is taken, and then a final decision is made whether this is a fraudulent transaction or not. This is done real time, and this is happening while the customer is still waiting at the point of sale. So these are typical use cases of fast compute. Again, if anyone missed to register themselves, this is it. Thank you very much.